Good afternoon. So, as John said, my name's Eleni Papathanasopoulou. I'm from the Plymouth Marine Laboratory and part of the team that actually put this project together. We're quite a collective a mix of scientists in this group. I'm an economist actually by background, but we also have our environmental our Earth observation scientists in the group, as well as our visualization scientists. So you'll see that not only are we a mixed team, but we also approach this project to ensure that our interests were translated into needs for DEFRA from those interests as well. So from an economics interest, from an environmental assessment interest, and from a visualization interest. The project actually was contextualized through the premise that the UK, along with a lot of countries which bound oceans and seas, are looking for the marine environment to be a key strategic area for economic and more correctly sustainable economic growth, which allows the safe, sustainable, and integrative growth of countries in the future. But it's not all about growth. Along with growth is the protection of the marine environment. And there's many various directives, recommendations, and white papers which are within the UK ensuring that the marine environment is also protected. So as we see, we have the Marine Strategy Framework Directive. This really looks at ensuring that the environment reaches good environmental status by 2020. And this is championed by a specific group within DEFRA, looking at the marine environment assessment and reporting. Then you also have the ecosystems approach to policy assessments. This was encouraged by the UK National Natural Ecosystem Assessment Report, suggesting that the UK government and its policies are assessed through an ecosystems approach, which means that you don't just look at the environment impacted, but also around the ecosystem services that the natural environment provides. And so here again, we have an individual team looking at marine evidence and strategy. And then finally, the Natural Choice White Paper, recommending that all natural capital is valued. And the reason why we value the natural capital is in many instances, there are services, goods, and amenity values which are often forgotten. And when we forget those, then policies and interventions are sometimes done with the detriment of the environment. So here we see quite a varied group also within DEFRA with very many different policies trying to ensure that the environment is protected. So we thought, well, what could we do that would allow a single database from Earth observation to be used, to be interpreted differently, as we've heard from earlier speakers, that would be useful to each one of these teams specifically. And one of the most fundamental products that Earth observation provides is chlorophyll concentration in the marine environment. So what we decided was that we'll take chlorophyll concentration as our starting point, and then based on published, scientifically sound research that's gone already ahead, we will take those algorithms and translate these chlorophyll concentrations into useful end requirements. So for the MSFD directive, we were looking at the eutrophication indicator 5.2.1, which is chlorophyll concentration in the water column. For the ecosystems approach to policy assessments, we looked at the carbon sequestration potential, again, fundamentally driven by chlorophyll concentration and primary production. And then from there, we also looked at valuing this carbon sequestration service by adding a price. I'm going to just demonstrate to you how the logic worked with each of these approaches and the database that we used. So here we took the database from the Ocean Color Climate Change Initiative of the European Space Agency, and we took chlorophyll A concentration. And these database is merged archive from MODIS, Aqua, the NASA CWIFS, and the ESA MERIS. And so what you are starting to get is an idea of the data that's there with very little data gaps. Within this chlorophyll concentration, we then turned to our technical leads in CFAS to identify what were we actually looking for eutrophication. And within eutrophication, it's defined that you have two levels. You have a 10 microgram per liter, which is identified as a medium eutrophication level, but then you also have a 15 microgram per litre, which is considered a high eutrophication level. So what we wanted to do was to flag these systems when they occur in the UK waters. As you can see, the data set is more than just the waters that would be of interest to the MSFD monitoring and reporting. But we're going to mask the information that is not of importance to us, but bearing in mind that this can be opened up to international waters and therefore exportable. So here we see a first result. There's very little to see, I'm glad to say. We see that in Edinburgh and the north of Wales, we do identify eutrophication at a very specific point in time. And the eutrophication is flagged yellow when the 90th percentile is over the 10 micrograms per litre, and red when it's over the 15 micrograms per litre. The beauty of this is that not only does it complement the in situ monitoring that already occurs, but it gives you a huge spatial and temporal flexibility that you didn't have before. So when we talk about what is influencing eutrophication and what can we do to manage it, this is one of the ways that we can start interrogating that data a lot more. So that's what we did for eutrophication. Then we moved on to carbon sequestration potential. And the carbon sequestration potential is influenced by temperature, depth, and sediment traps. And along with these, again, the algorithms have been published and recorded. So we're not doing any new research, but what we want to show is that the data is already available and we can capitalize on Earth observation information. What we produced here is using an algorithm of data of waters around the UK and taking the chlorophyll concentration, we now are able for the first time really to look at UK waters with a different perspective. And this is an ecosystem service that the waters in the UK are actually providing. They are sequestering the carbon from the atmosphere and storing it in many ways that will help climate change, well, at least the carbon dioxide in the atmosphere be sequestered for a time, reducing the carbon dioxide intensity in the atmosphere. And here again, we're looking at a scale where the blue is a lower carbon sequestration potential and the red is the higher. What this allows you is it gives you a different dimension to marine spatial planning. So where you are looking at where businesses are profitable, close to the coast, further away from the coast, specific type of activities, this now also gives you an environmental perspective that, well, the water, regardless that if it's profiting companies or not, is that it's providing a service which is as valuable. And this is where that natural choice came into it, is that we have to recognize that there are also services. And by multiplying these tons per year of carbon dioxide equivalent by a relevant price, and that which is suggested is by DEC, which is a non-tradable carbon price, which for 2011, which is what this map is showing you, is about £52 per tonne of CO2 equivalent per year. You can then also get a value. So once again, you now have a map, which, because of the linear multiplication, actually looks the same as your carbon dioxide potential, but it talks the economics language and it talks the natural capital language. And so what we see here again is that we are able to identify where our valuable waters for this specific service is. So this is quite a place to come from raw data. Yes, there is algorithms that are run by experts, but once you have the understanding, the interpretation by the end user, the next step for us was to ensure that it was easily accessible. So after a workshop where we talked with the DEFRA end users, which were the MSFD monitoring team, the environment evidence and strategy team, and the natural capital team, we wanted to try and provide them with a web-based interactive portal. We wanted to speak to them to understand, could they use this data in an easily accessible way, and then how would they need to use it further afield. So this is the beginning of our portal. It's publicly available at the moment, and so would be interested in any feedback. What it provides is firstly a blank map and then the menu bar on the left-hand side with the 3 available indicators in the very bottom of the field over here. So you can either select an indicator type or a region, and then depending on what those indicators have underneath the content, this appears. So we have our ecosystem services, which would have been your carbon sequestration potential, your MSFD indicator, which would have been your eutrophication, and your natural capital. And this is just a structure, so these can be increased with time. So if we just choose the MSFD indicator, we see the MSFD eutrophication 5.2.1 comes up. And then if you were to choose that, it gives you a map of both where eutrophication is occurring. So again, the north of Wales, and a little bit further up the coast as well. And then it also gives you a scale. So this is in milligrams per meter cubed. This should be orange and red, so it has a little bit of flaws, but we're working on it. But these should be, that's the 10 microgram or milligram per meter cubed flag, and that is your red one. So here again, you could have a look. Specifically, we just took the year 2011 at the beginning of July. So here again, we're starting to identify particular seasons and particular activities where eutrophication is occurring. Another layer, which we've also uploaded, is the carbon sequestration potential throughout the whole UK waters. And what the beauty about this is that not only do you have a visual idea of where your services are occurring, but we also have started to work on a little bit of the analytics. So if you were to press this graph over here, just for all the waters, what you get is for every year, 98 to 2011, you get an average of the carbon potential and how that trend is working over time. So if you had other services as well, you could see how different policies and different interventions were occurring. So after the workshop, some of the feedback from the DEFRA teams was that the project had made some useful progress, particularly on the use of Earth observation with regards to eutrophication. And there is the potential of these kinds of maps and these kinds of activity help achieve savings in the future. And also the visualization looks good and has the potential to contribute to the development of natural capital accounts. The next steps for us are really to try and look a little bit further into what we produced. The pixel that we used was 4 kilometers by 4 kilometers. So whether we can get to a lower resolution with not much more processing power, how far closer to the coast we can get as well for clarification, the spatial and temporal dimensions as well. That will all be looked at as we go further. We want to extend the monitoring, ecosystem services, and valuation capabilities. We just looked at eutrophication and carbon sequestration. There is the potential also to look at fisheries as well in the future, and explore other end users nationally and internationally. So as the EU directive applies to all EU countries, there could be quite an easy translation to the EU waters depending on spending budgets. Conclusions, well, we found that the Earth observation data that's already there is of huge use, and by different teams within DEFRA. We wanted to understand if one data set could be used by multiple teams, and yes, it can. There's a flexibility in reporting outputs at any scale required by the user. At the moment, some monitoring requires just a 1-yearly reporting system. We can show that if you start to look at different spatial and temporal, it provides you a wealth of knowledge that will allow you to manage your natural database a bit better. Easy access to data and updates from web-based. We've also heard that there's real-time updates here as well. So if something happens, the database will update within a day, and that the potential for further capitalization on existing Earth observation products. We know that there's a lot being done with SARS, and there's a lot of MSFD indicators which don't just use the visual spectrum. So we would really like to work with people in the future to ensure that this is a tool that covers quite a lot, if not all, the MSFD indicators as they come. Thank you.
Thank you, Eleni. Are there any questions for Eleni in regards to this project? One in the middle, John.
Sorry, it's just a very minor question based on me not listening properly. You've just said it's updated daily when the information changes, is that right?
Well, from what I understand, it's almost real time. So as soon as the data is delivered, we can process it, and it just depends on if we have someone doing that manually or if it could be automated.
Okay, but there's probable plans for it to be automated into the future. Okay, that's awesome.
Yeah.
Any further questions for Eleni this time? No, we'll just to say thank you very much, Eleni.
Thanks.
She'll be here at the break, so if there are any follow-up questions, that would be there.